2. A grain boundary is the interface between small crystals with differing crystal orientation, or grains. The natural formation of atoms and grains is in a hexagonal close-packed arrangement, as the atoms are completely surrounded, thereby minimizing their energy. Crystal defects occur when bonds are broken or atoms are no longer completely surrounded, and grain boundaries are formed along the mismatch in crystal structure. As the grains become misaligned with one another and the angle between them becomes larger, the amount of stored energy in the crystal increases. One way to visualize and study grain boundaries and crystal defects is through the use of bubble rafts. As you can see, the bubbles, representing atoms, have naturally formed into a hexagonal close-packed arrangement, with each bubble surrounded by 6 other bubbles. Where the bubbles are not completely surrounded, there is a mismatch in crystal structure. This leads to grain boundaries, as is exhibited by the bubbles. In long-range crystal orders, volume defects occur in the form of precipitates and voids. Precipitates are impurities introduced into the crystal that are different from the crystal's primary grains. They can be substitutional, which are larger than the primary grains, or interstitial, which means they are smaller than the primary grains. Voids are clusters of vacancies, which are point defects. Due to thermodynamic considerations, vacancies diffuse through the crystal and cluster together at grain boundaries, forming voids. Like precipitates, voids cause lattice strains, altering the microstructure of the material through interactions with dislocations.
This allows the material's use and biological responses to experiments to be controlled. An example